Welcome everyone to today's meetup. So let's start. Welcome. Today's meetup is organized by AWS Budapest Community of Practice, which is mainly focusing on AWS Amazon Web Services topics. And now this is a place for talks, discussions, where we can share the knowledge and experiences. That's why the Budapest Community of Practice was formed. So please feel free to join these discussions and ask questions. Before we start, let me remind you that we regularly organize these kind of events. So feel free to join AWS Budapest Community of Practice, be a member so you don't miss out on these opportunities. We will have two topics today. I will cover the first topic. This is step function in actions. And the next topic, the RDS Terraform using Terragrunt modules. So just a couple of words about me. My name is Csaba Szegedi. I work as an AWS solution architect at Deutsche Telekom IT Solutions. I'm also an AWS community builder, and I also do technical trainings for AWS. Now, my presentation is about step functions. I will present you a concrete project of mine, a hobby project of mine, which started a couple of years ago, end of 2019, beginning of 2020, when the COVID pandemic started. And actually, my story is also related to COVID, because it's something which is built to help solving the problems, or at least I try to use this solution to help solving these COVID problems. What I could do from my side as one single person. So the solution which popped up at some point in front of me is called Folding at Home. Folding at Home is a distributed computing project which studies protein folding, misfolding, aggregation, and related diseases. This community uses novel computational methods and large-scale distributed computing to simulate timescale thousands to millions of times longer than previously achieved. So using this distributed computing, this could be achieved. In this community, folding refers to running simulation of proteins. The molecular machines that perform most of the active processes we associate with life, like breathing, muscle contraction, sensing light, digesting food, these kind of molecular machine performance. So using this folding at home, they exploit the biological insight this simulation provides to inform drug discovery and other efforts to combat global health threats. So it's not only solution for COVID-19, but also for other diseases, Alzheimer, cancer, etc. So Folding at Home reacted on this pandemic outbreak of COVID and included related protein folding simulations into their solutions and made this solution as a default solution. So in 2020, when I found this solution, I also started to use my machines and do folding. So I joined the community. At that time, many others also joined. So you could see here, this is the year 2020. Still in March, there were only like 30K machines, users using Folding at Home. With a big bang here at the end of May, we already were more than 1 million machines users in this distributed compute solution. Unfortunately, COVID cases were also rising, but what was really interesting and astonishing that with this above 1 million machines, we reached above the exascale barrier with this distributed computing solution. Back then, the fastest supercomputer was like at 200 petaflop scale. So we reached much higher scales with this community. In 2022, I guess the Frontier, USA's most powerful supercomputer, was also reaching this exaflop barrier. Okay, here on the left side, you can see the world map. The dots not pointing out the COVID cases, but the machines joined to this community. All right, so not only persons like me were joining these calls. Also, big players joined as supporters at Folding at Home. So NVIDIA, Microsoft, Oracle, and also AWS joined as a supporter. Lots of other folks were also writing blog posts showing solutions how you could share some computing resources on AWS also. So I was also thinking that beside of two of my machines, my PC and my notebook, what else could I share and how could I give to this community even more? I had some unused AWS credits received from different events, received from the authorized instructors group. And some cases, I didn't use up these credits. So imagine these credits, like, for example, I received $50 credit from one of the events which I joined. And I can use these credits in AWS to run anything. So I had these credits and I started to start up some EC2 instances and used those as Folding at Home solutions. But at some point, I noticed that these EC2 instances are not used optimally. First of all, using on-demand instances was expensive. Second of all, if I use only CPU instances, that wasn't folding fast enough. So I needed GPU instances. But if I use GPU instances and on-demand, that was too expensive. Okay, then let's see the spot instances. Spot instances are much more cheaper, like 70% discount. There are on spot instances where I'm using the unused resources of AWS. So I started to use spot instances, but still wasn't optimal because I didn't receive folding jobs all the time. So there were some idle times when my EC2 instance was running, but there were no folding jobs received. So I thought further and eventually ended up with this diagram, which you can also see here. So Folding at Home service is here on the right side, running in an EC2 instance. And all the other services were built just to create a life cycle for my EC2 instance, so which would be running mainly when there is a folding job running on it. So all these start, status, pause, revive, terminate Lambda functions were created to handle this EC2 instance. Now, all these steps were orchestrated by a step function workflow. So that was the brain of this whole solution. I was also using a DynamoDB to store the external state of my solution. And I also used some queue where another service which I created could send out internal information from my folding service. Okay, but let's just quickly go through these steps. Before that, I already mentioned the resources. These resources were deployed by the serverless application model. Serverless application model is an open source framework for building serverless applications on AWS. Shorthand syntax to express functions, APIs, databases, and event source mappings. SAM template is an extension of CloudFormation templates. I don't know if you work with CloudFormation. It's an infrastructure as a code solution. You will see lots of examples also in Roland's code, just another type of infrastructure as a code. It won't be CloudFormation, but it's Terraform. Okay, so serverless application model is there to build and deploy these resources into AWS in a repeatable manner. Not only serverless, but also CloudFormation resources can be also included. As you can see, a serverless application model isn't creating the EC2 instance. That's why I deemed that. So I left only those resources which were created by this serverless application model. Okay, so these were the resources created. And then let's go to this life cycle and to see when my EC2 instance was created. So the first step, which is triggered by the step functions, to start the folding, I need to start an execution of my step function workflow. And there, the first step is the start task, which requires a credit and user tag input. In the credit, you can specify dollars like $3, $5, $10 credit. And the user tag is something which you define, a name or something which identifies your workload, whatever, which will be used to tag these resources. Okay, then start, a Lambda function will start an EC2 instance, a spot EC2 instance if it's available. If it's not, then no other instances will be started, but the step function workflow will wait for the next round to try again to find a spot instance. Okay, so on the EC2 instance, we have the folding at home service prepared, the service which was written by me, which checks the folding at home service directly in the instance. And then we also stores the state in this external status store. Now we have to wait a couple of minutes until the whole system is initialized. So we are monitoring the system, what's happening inside of it. This monitoring will be done by this internal service, which sends regularly some data to a queue, simple queue service of AWS. The messages from this queue are consumed by watch Lambda function, and the information received there are stored again in this external store. So we see internal information and external information from the EC2 instance. The external information are always retrieved directly by the status Lambda function. The status Lambda function is regularly executed. So external information which are directly requested from AWS itself, from the AWS EC2 APIs. The internal information will be retrieved from the status store, which is a DynamoDB, a NoSQL data store. Okay, so this is running regularly. And in some cases, in this status, we will see some information which will force our system to go to sleep, to pause the system, which means that the EC2 instance will be stopped and we write into the folding status information that we are in pause state. Again, regularly we'll check if we are in pause state, and if we are in pause state for long enough, then we will revive our system, which means that the EC2 instance will be restarted and the folding will be running again. Okay, status store is also updated. And the last step, which is executed and triggered by the step function, is the terminate state. This is when our configured credits are expired and our EC2 instance will be terminated, status updated, and that's all. That's what will happen during these steps. Okay, so that's the environment which is created by the serverless application model. And then the step function itself is a service which is orchestrating all the actions, all these lifecycle actions. Okay, then step functions, that's why we are here, right? So step function is a visualization workflow service that helps developers use AWS services to build distributed applications. Mine is also distributed applications, automate processes, orchestrate microservices, and create data and machine learning pipelines, etc., etc. Lots of stuff can be automated with step functions. Now, step functions do have different steps. One of these steps is the if then else logic, a choice statement. In this case, you can take different paths to follow based on the input which is received by this step. You can execute parallel statements, so create separate parallel executable branches. You can run parallel workflows for each of the items in your dataset. So step functions will iterate through this map. You can simply create pass statements, which simply is just a placeholder or can transform your input into another format of output. You can have wait steps, which delays your function for a specific time. Then successful, failed, these steps can also be executed. Okay, other actions can be invoked, of course. These other actions are AWS services like Lambda, SNS. You see here the most popular services, but there are tens of other services which can be used, triggered by your step function. Okay, but what is inside our step function? This is my step function solution, the whole workflow. Let me just zoom in here a bit so you could see that more details. There is a start and an end state for my function. You can see two bigger blocks here, the init and the fold block. These are parallel states. You can see here from the icon. I don't have anything running parallel here. I just created these blocks because I want to have my error handling to be done at one place. So this is a good practice solution to add these parallel blocks and have the error handling for the whole block at one location. You can also try to add that to your solution if you haven't used that yet. Okay, in the init state, we call this the start lambda function. The start lambda function goes to EC2 and tries to start the spot instance. Won't check anything in the status, or the result of this execution will be checked by the step function itself with using a choice state. We will check here if there was a spot instance available or not. If there was no spot instance available, then we go back to the lambda function, or we wait, I don't know, for 30 minutes, and then we try to start that spot instance again. So spot instances are not always available. That's the point here. If there was a spot instance available, we are happy. We go further to the folding block. Okay, folding block contains a lot more logic. We have a simple pass statement as a placeholder where we manage the input and provide further for the first wait state. So here we are waiting, so our system is initialized. And after that time expires, we go to the get status step. With the get status, we go to the DynamoDB table. We get from there the internal state of our folding. We go to the EC2 to get some external state about our EC2 instance. Again, we just gathered this information and we provide that as an input to the check status choice here. Yeah, there could be lots of outcomes from here. The happy pass, the default pass, is when we go back and wait for further foldings. It means that everything is running well. We just wait until this folding is happening. We also go back to this wait folding state when we are not sure what's happening with the system. So we just wait and we'll check again in a couple of minutes. Now, in case when the folding state is idle, here it's not visible, but it's checking for idle, that's when we go to the pause state. From the pause, here this is when our EC2 instance is stopped and the DynamoDB table is updated. Then we wait there for 30 minutes, 60 minutes, depends on the configuration. And then we go to the revive state. Here we will restart our EC2 instance, and EC2 instance, if we have spot instances where we can revive, then we go and wait for the further foldings. Okay. So again, we are live again, waiting for foldings. Of course, we could get back to this pause state a couple of minutes if we don't receive a new folding job, but if we receive then we are just circling around here. If there are no spot instances available when we try to revive our system, then we go back to the state when we wait for folding task. Eventually, our check status will see that our remaining credit has expired. So our remaining credit is 0. That's when we exit this block, this fold block, and go to the terminate state. This terminate state, we terminate the EC2 instance, and we go to this choice state where, again, we check the termination status. We do that because it could be that some error happens in this folding block, and we reach this terminate state from that point, and it could be that we have some credits remaining. So if that's happening, we do restart the whole system with the remaining credits. So we don't just leave that there hanging. In case of error happened, the whole system can heal itself and do the foldings further. Okay, but if the credit was really expired, then we just go to the end state and exit the step functions. Okay, so that's the internal of our step function, and that's how the whole life cycle goes on. And during that, the folding and the simulation, the protein folding simulation is happening. The code behind this is implemented via the Amazon state language, which is embedded in the serverless application model template of mine that can be included, but of course this can be implemented outside of this serverless application model template. Here you see how these states are defined, the init state, which has a type of parallel, where I can define the branches. I have only one branch here. And then inside of that, I have the other states, calling a Lambda function, which has a type of task. Choice has a type of choice. Okay, we can check this in more details on the management console. So I will move over to here to the step function. Okay, so this is in the management console. This is the welcome page of AWS Step Functions, where you can have and see lots of useful information like API references, FAQs, blogs, videos, forums, etc. I already have the state machine deployed. So with serverless application model, I have this folding state machine deployed. As you can see, I already had lots of executions. Some of them succeeded, some of them failed, aborted. But yeah, this is the dashboard of your state machine, which you can edit or start the execution. Okay, if you are editing your step function, on the left side here, you see the Amazon state language code, which in this case is in JSON format. So it's able to be converted between these two languages, JSON, YAML. That's not a problem for the service. Okay, so here is the full code. I won't go into details of that. It might be interesting, but let's just skip that right now. In the Workflow Studio, that's the other point where you can edit your step function. This is the diagram which I was also demonstrating to you on my PPT presentation. Here are the actions which I mentioned, the other actions from compute, from storage. So lots of these other services can be used directly in your step function and build a whole microservice environment using this solution. Okay, but I will exit now the edit mode and I will go to the start execution. Now to start execution of this folding, I need to specify these parameters. I need to specify the credit. Let's just give a $5 credit here. And I need to specify the user, which let's do it like Budapest Community of Practice. And let's start the execution. The execution is started. You can see here that the init block is just being executed, or it's already been executed. It was started successfully, so there was a spot instance available, which means that we didn't have to wait for the spot instance. We could go directly to this next state, which is the folding state. In the folding, we are already entering the wait folding state. We are waiting for the initialization of the system. We don't have time to wait for the initialization because that would take a couple of minutes. So I will just move to one of the earlier executions and see that the whole function eventually went to the end state. You see there were like almost 3,000 events happening during these executions. It was a happy execution, so wait for spot wasn't executed and didn't even had to go to this pause state. All this folding was successful. My execution always received these jobs. Okay. I will check another execution here. This was also happy pass. I had somewhere here one which also entered to these different states. I'm looking for one where I also have the, okay, wait spot not. Yeah, there are lots of more executions, but again, this is also a happy pass. I had one somewhere, but currently I cannot find that. Okay, what else I wanted to show to you is during these executions and as important monitoring or examination of these Lambda functions is using these execution periods. Yeah, execution events, sorry for that. So for example, if I go to this get status step, I can check its input and its output. So what was the payload? This is the payload, some information about my EC2 instance, like IP addresses, basic credit. This is just a placeholder right now. The email address is not used. Remaining credits, that's what I can see here, how many credits I still have remaining from my instance. I can see the price of my spot instance, public IP address, instance type which is used, etc., etc. And I also doesn't really matter. Oh yeah, well, found that. Okay, this is where all steps were accessed. And yeah, this is where I have some extra information where I can see that the status is in folding state. I receive, in this case, CPU tasks. But of course, this is only one get status task. If I go further down, I should be able to find some GPU. No, not GPU. If I would see GPU related foldings, I would see here that because folding at home can do CPU and GPU related foldings also. I saw that quickly. I had a glimpse on one of the questions. I can quickly answer that. What's in the failed executions? The failed executions, you see clearly that this was a failed execution. Here you can see that there was the input, there was an error like something with the basic credit. The error was that I was using here the capital C instead of lowercase c. I had some update here in my code. Some older failed cases, you can see here that the failure happened in the fold block. Here the get status, if I see the details, here the cause, invalid literal for int. Yeah, that was also some coding problem here, which I had to solve here. Okay, eventually this was, I would say, an unsuccessful, really unsuccessful execution because the termination itself was also failing, which means that my EC2 instance was running there. So I had to fix this issue in my code so I could have the execution correctly. Okay, so this was a quick glimpse on how this folding at home service is running. If you would like to execute that on your own, you can also do that. The environment, the whole solution is available on GitHub. I made that as an open source. You can also play around with that. I have the description, how to deploy that. So using the SAM deployment, how to start the execution. Yeah, and please keep in mind to check the troubleshooting, because it could be there are some manual steps which might be needed to be executed. This is when you have this max spot instance count exceeded. This is when your execution would remain in the same waiting for spot case. You have to request for your AWS account these G4 instances. And yeah, some error cases can also be examined in that troubleshooting section. Okay, and I think I reached the end of the time which was prepared for me. And we can go to the Q&A sessions, okay? I already saw a couple of questions coming in. First question, how does your step function know if there is a new folding job to run it? My step function will be informed by the service which is providing the internal information. So I have this Linux service which is examining the logs of the folding service and is sending regularly this information to this queue, and my watcher will update the get status, and then the status Lambda function will see that the folding at home is receiving folding jobs. If not, then we'll see it as an idle and we'll stop the instance. Okay, what's in the failed execution? I already answered that question. Can you share GitHub URL If you can just read this QR code. If there are no other questions, thank you for your attention, and I will give further the word to Roland Lavati, who is my colleague at Deutsche Telekom IT Solutions, will present you RDS related Terragrunt modules.
Hello everyone, my name is Roland Lavati and I work for Deutsche Telekom IT Solutions as a data architect, which basically means AWS solution architect specialized for data topics. Today, I will talk a little bit about infrastructure as code, Terraform, Terragrunt, how they work. We will check the custom Terraform module code I prepared, explore our Terragrunt tree, copy a Terragrunt HCR from one environment to the other and deploy it. I hope you will find it interesting. This is my first event as a speaker, so I'm very excited. Let's start. So, what is infrastructure as code? Infrastructure as code is a concept and practice in software engineering and DevOps that involves managing and provisioning infrastructure using code and automation tools. Traditionally, setting up and managing infrastructure like servers, network storage, and other resources required manual configuration, which could be time-consuming, error-prone, and difficult to reproduce consistently. Infrastructure as code addresses these challenges by treating infrastructure provisioning and management as a software development process. There are two types of approaches. Declarative, where we are defining the desired state and the system will apply the necessary changes to reach that state. And imperative, where we are using step-by-step method to define the requirements, and these must be followed to reach the desired configuration. Terraform uses the declarative approach with configuration files written in HashiCorp configuration language. You can use it in the cloud for single or multi-cloud setups, on-premises, or in a hybrid environment. Terraform uses providers to interact with the target platform APIs. HashiCorp and the Terraform community have already written thousands of providers to manage different types of resources and services. Terraform uses state files which act as a source of truth, and these state files can be managed locally or remotely. To work with Terraform, you should follow the core workflow, which consists of 3 stages: write, plan, and apply. In the write stage, you define the infrastructure in your configuration files. In the plan stage, you review the changes Terraform will make to your infrastructure. And in the apply stage, Terraform provisions your infrastructure and updates the state file. Terragrunt is a trim wrapper that provides extra tools for keeping your configuration dry, working with Terraform modules, and also managing remote state. You will see these in action during our live demo. You can find some pre-made Terraform RDS modules in the public Terraform registry, which are ready for use. You just need to reference them and pass them the needed parameters. So why would you create your own? To create an RDS instance, you have to create multiple resources. You have to have a database subnet group, a parameter group, an option group, and an instance. These are the core resources. But you may want to add, for example, a security group, a secret, which contains the password of the RDS admin user, CloudWatch dashboard, and CloudWatch alarms, root 50T record, or some custom scripts to execute after the database has been created. You may not find an RDS module that deploys all of these resources for you, but if you write one for yourself, you can encapsulate all the resources you need. If you create your own module, you can simplify and enforce naming convention for your resources, so they will follow a standard naming convention. Also, next to the naming convention, you will want to automatically tag your resources according to your tagging convention. You can get also built-in security with input validation and defaults. In the demo, I will show you an example for validating a parameter group parameter and also option group settings. Do you need to create a new RDS instance as soon as possible, which is compliant to your company in every way? Just use your module as a source and change only the parameters which needs to be changed, and you are ready to go. Do you want to add or change something? Just do it, and when you are done, increment the version tag in Git, and you can start your deployment. And now it's demo time. So we will use a sandbox account where I already made some preparations. In the demo, we have two environments, dev in EU West 1 and prod in EU Central 1. In dev, we have a VPC and we have a RDS instance in that VPC. In the prod environment, we only have the VPC for now. So this is the dev VPC. This is the dev RDS instance, which is in the dev VPC. We don't have any other databases here in Ireland, but if we go to Frankfurt, that will be also empty because we don't have it yet. Okay, so our first task is to deploy a new RDS instance for demo app in the prod environment with the same settings as it is in dev, except the instance type should be dbt large instead of the db3 medium. And of course, the naming of the resources should reflect the new environment. I wanted to start with this deployment first because it will take approximately 10 minutes. So how do we do that? This is our Terragrunt team, and I will just quickly start the deployment, and after that I will tell you more about this. But this is the dev config, and I just copy it in the prod config. And I delete the cached files because we don't need that. And I jump here to a Terragrunt plan. And what this Terragrunt plan does is that it basically initializes the backend, it downloads the providers and the modules, and it is also planning the execution for us. And it finished. So what does it want to do? First, it wants to read the secret and the secret version. And it then, so this is not linear, it is just, this will be read after the secret has been created. It is not created yet. So it will deploy an RDS instance, an option group, a parameter group, a secret version, and in that secret version there will be a random password which we also generate. So I will start apply. And so it started to work. So now that the deployment is underway, let's check out Terragrunt configuration. So this is the first level of configuration. Here we have two regional folders, and global and vars.yaml. And this vars.yaml, this is like a global configuration file where we grouped our configurations for the environments. And you will see later how this is done, how we will use this. And for the global section, you can put here policies, roles, or Route 53 zones. In this demo, we won't use those. And so let's go into one layer deeper. And there it is, an environment folder and the Terragrunt HCL. And so what have I changed in our local setup compared to what is in Git right now? So in Git, the backend is a local backend. There is no real remote backend. But I changed that for the demo to an S3 backend. So I can show you the state files on S3 and also the logs in DynamoDB table. And if we open this, then we will see that, yeah, the backend is configured as S3, and this is the bucket where Terragrunt will store the Terraform state files. This is the how it will show in what format. And this is the region, and we are using encryption, and we are using a DynamoDB table, which is called Terraform logs. Yeah, so basically this generate thing says, which is also here for the provider, that if we are going deeper in this tree, and if we are referencing this configuration, then every module which is deeper than this will inherit these settings. And you will see that example as well in a minute. And if we go deeper, so here is that, there is the service and the VPC. And here we have only an identifier. So let's go into VPC. Here, this is the Terragrunt HCL. So this is where we basically define what we want to deploy. And here we define the source where the module which we want to deploy is right now. This annotation basically is the 3 slashes here. This means that we are using Terraform public registry. We are using this module there with this version 5.1.1. So basically, if you go into the modules Terraform registry page, and you will see that to deploy this module, you will have to use this source, which is also in my Terragrunt HCL, and this version. And this works with Terraform public registry. And here is the include block, which I said that it will search for the parent folders, and it will load this Terragrunt HCL settings for us for this module. And here I reference the global values and identifier, which are also upper there. And in the inputs, here we are passing the parameters for the module as input parameters, as input values. Yeah. And here in this folder, we have this dependency log file, which is basically the same as for Terraform. It is storing the provider version. And when we go into this Terragrunt cache, you will see why is this a wrapper. So basically, the module which we referenced will be downloaded here. And here is the backend.tf, which was generated by Terragrunt. The provider.tf, this was also generated by Terragrunt. And this is where the form is running. Okay, so this was the VPC module. Let's check out now the Terragrunt HCL for our RDS module. Here, I'm using a different annotation. This can work with any other Git repositories. And here, this says that I'm using this GitHub repository of mine. And this part says that in this Git repository, you should use this path for the entrance or for the entry point of the module. And we are also specifying a tag, this v0.0.1. And here is also the include, which we saw in the VPC module. And we have also a dependency here. This dependency does that we can reference the outputs of the VPC module in our module here. And we will see how I use this. And this is also, we saw some of these in the VPC module. So we are reading in the configuration files and processing those configuration YAMLs. And here we use an application ID for naming our resources, and this database number is also for naming convention. And we said that the availability zone should be the regions 1, the regions A zone. Yeah. And the others are just, we are passing the values to our RDS module, which I wanted to show you is that here, while the deployment is running, here is this DynamoDB table, and here you can see that this is a log file. So basically, if anyone wants to modify my resource, which is now under deployment, he will get an error that this resource is logged right now. And after the deployment is finished, then a digest will be updated, and also the resource will have an MD5 postfix. And here is the bucket in which there are the state files. So let's check out our Terraform module. It was built like that these are the submodules when we are defining option group and parameter group and secret. This can be used in a entry point module or in a main module. Why is this handy? Because if I would want to create a Postgres module, for example, then I could just copy it like this, and I could reuse all these modules. Only the specified values should be passed onto them. It would just work. So, and here is our main.tf. And here we have a sensitive value. This is the credentials of the secret. So the values of the secret, a username and a password, and it is flagged as sensitive. So this won't be shown in output variables or in log files. This is how we are doing the naming convention enforcement. That here, basically, we are putting together the naming convention from the region code, the environment, some constant stuff, the application ID, which I showed you, and the database number. This is also the RDS major engine version. We put that in here. And here we are calling this our submodule, which creates the secret. And we are reading the secret from AWS through this data source. Here we are passing the parameters for the parameter group. Here is the option group, and here is the RDS instance. And yes, and so this is how you encapsulate the different modules into one, so you can use it. What I wanted to show you is the validation. So here in MariaDB, you have a parameter which is called require secure transport, and this has to be 1 so that the SSL connection will be enforced. So you cannot connect to it without SSL if this parameter is turned to 1. And this parameters is a list type so list map string type basically. And how can we validate that this parameter is always in our configuration? So there is a validation for that goes over every element of the list and check if the map name key of one element has the required secure transport string and also the value of 1. And if this is true, then we are okay. If this is false, then we will get an error. And I will just show this to you right now. So I'm already in this folder, so I can just do the magic here. So I will copy and paste it. Like this. So if I run a Terragrunt plan right now, nothing changes. It will say that no changes were detected for your infrastructure. But what if I want to turn this off? We received an error that require secure transport must be set to 1, and this is what we wanted. If I change this back to 1, then we are fine again. The other thing, which is a little bit more complex, is an option group. So basically, MariaDB has this audit plugin option group, and it is a more complex variable. And it should have an option name and also option settings like this. This is just a sample I put in. We can validate it like this. So basically, this says that it is looping through all the options. And if it finds an option with this option name, then he wants to have these option settings as well. And if you have more, then it is not a problem. But if you have less than these two, or there is a different value, then it will also throw an exception. And we can check that out as well. So, what if I just want this to be 30 instead of 50? We get the error that the variable MariaDB RDS option must contain the specified structure with MariaDB audit plugin settings. So yeah, this is working as expected. Yeah, and let's check out because the module was deployed. So it is indeed here. And it has the prod in it, and it is U Central 1 resource and also demo. It is in the prod VPC. It is using the tags which we provided. Most of these in the global variable file, but we added also some in lower levels like this name. And I wanted to show you multiple things. So yes, so what if we want to deploy another database? How can we do that? So we have this demo app, and we have the task to deploy a database for Kula. All we need to change is we just change this application ID. Nothing else needs to be changed. You can change other things, yeah, but if you want a database with the same settings, you just do this. You just go into this folder. And you can get cool up with this change. Okay, and one more thing. What I wanted to show you is that we can go back here into this directory. And so we want to extend our module because we don't have the performance insights enabled. And we want it to be enabled. So how do we do that? We do it like this. Go into our module. There is an option, this performance insight enabled. This solution says that, yes, we should upgrade the module. So in further module releases, the performance insight could be enabled by default, because otherwise you could create a parameter which can be set to true or false. And normally you could do this if you are working on a live environment. You could just commit it and push it and tag it with a v002 tag. In this configuration, you would use that tag. but I won't do that for now. Show you how you can use it without pushing it to Git repo. You can reference your Terraform module repo also locally like this. And if you go back to the not this console, and we are doing the Terragrunt plan. Then it shows us that he wants the performance inside enabled flag, which is false by default, to turn it to true. And if we would apply this, then it would turn on performance inside with the default settings. But I won't do that because it would take some time and we are out of time. This is the demo I prepared. Now it's the question time. Here in the slide, you can read this QR code. You can check the source code, which I showed you. And also here is my LinkedIn profile. If you have additional questions, you can also contact me. So basically, Terragrunt can be used instead of Visual Studio Code, for example, to write the code and deploy it. Terragrunt is a wrapper for Terraform, which is working with this Terragrunt configuration files. It is Terragrunt HCLs. And with this configuration, you get more features out of Terraform. So this drive of your provider block and also your backend for the subdirectories and also other things I showed you. Second question, can you please summarize again what is the benefit of using Terragrunt with Terraform than without it? So in upper levels, if you write this generate HCL configs, then you don't have to specify those on lower levels. You can just call the modules. And to be honest, Terragrunt has many other commands and things I didn't show in this demo. So there are these run all commands and a lot of things. This was just a basic presentation. Okay, the third question, can I use modules only using Terragrunt or modules are a Terraform feature? So basically, Terragrunt is calling your modules, which are Terraform modules. So Terragrunt is using Terraform in the background. So you can only use Terraform modules with Terragrunt. But you don't have to write all the Terraform code if you don't want, because there is this public Terraform registry where you can reference the modules locally on your Terragrunt configuration file, as I did with the VPC in my demo. For the second question, one thing popped in my mind, so that you can diff setups between multiple environments if you want easily. And in Terraform, if you are using the workspaces, it is not that easy.
So the biggest advantage, in my humble opinion, is standardized dynamic remote backend. It even creates remote state bucket if it does not exist. It's more a statement, not a question. And for a multi-account complex deployment with many modules, you easily can make mistakes what backend is where. Any objections or agree with this statement?
For the first, I definitely agree, because I only had to specify these parameters and it worked out of the box. So yeah. Yeah, because of the tree structure. If you are defining these things up there, then you don't have to define it in lower places or define them at all in lower places. So it is easy to avoid the mistakes if these configurations are up there in one place.
Thank you, Roland, for your insightful presentation and for the deep dive demo. Thank you all for joining the current sessions, and thank you for the questions. Thank you again for the attention. Have a good day. Thank you, Roland. Thank you, Fanny. Thank you, everyone, for your help.